Here, start recording. And let's see, let's hide the cleaning trace. Okay, so this tutorial is all about debugging. So we're going to talk about some principles of debugging and then go through the function that we wrote last week for milestone 1. And you're going to see there's a problem, right? It's not working, and we're going to debug it. And then, time permitting, I'll give you a last group debugging exercise to practice. Okay, so why does debugging matter? Because bugs are not the exception, they are the rule. Almost nothing complicated works first try. I basically long ago came to the conclusion that any code I wrote would be broken, right? When I was done writing it, there's even a word for this, it's called code complete. It means you wrote all the code, you haven't tested it yet. So you don't say it, so you say code complete, meaning I wrote it, but it will not work. And that's the attitude you have to have. Until you test something, it is broken. Once in a while, you're surprised because it works. I remember one time when I had my startup company, I wrote 2,000 lines of code for a complicated algorithm. And then one of my engineers was writing another 2,000 lines for another complicated algorithm. We were going to put them together and see if it worked better. And we put it together and started running it through the debugger to watch it execute to find the bugs, and there were no bugs. And I remember that because that is the only time that ever happened, right? And we still spent several hours looking for the bugs because we were sure we must have done this wrong, but it actually worked. Okay, so it's rare, right? You should expect there are bugs in your code, and the assumption you have to have is it is broken until you prove that it works. So there are studies that say debugging and testing take 50% or more of development time. So it's not a minor activity, it's a big activity. And it isn't just for software. So for any complicated system, you have to debug it. You have to debug hardware, you have to debug circuit boards, you have to debug your car. There are complicated debugging problems for like cell phone networks. So new communication standard comes out, companies spend a lot of money setting up cell phone networks, cell phone towers, and they have many, many things that can go wrong, right? The antenna coverage pattern is bad, there are buildings in the way, they haven't configured the equipment in the best way, there's interference on this part of the spectrum, maybe there's something broken in the base station. It's a complicated debugging problem, and they have to do that, right? Well, obviously, else just can't put it up and say, well, it doesn't work. So why am I telling you all this? So that you don't think, oh, I wrote all this code and now I'm surprised I have to debug it. That is a key part of your job as an engineer. You want to get good at it. Okay, so it's a learned skill. You get better at it with practice. And while debugging is complicated, when you're debugging a complex system, these systems are not magic, right? They do follow the laws of physics and of nature. So you just have to think of the right ways to test it to get enough information to figure out what's going wrong. But when it's complicated, it is hard. And debugging can be very rewarding. So it's a difficult thing to do. It's a creative pursuit. How do you figure out efficiently what's wrong? And it's a key skill. So one of the questions that I asked people when I was hiring them at Altera, or interviewing people at Altera, and one that I asked of all my potential grad students, when interviewing grad students, is tell me about a difficult debugging case you had. So something that was hard to make work, what you did to figure out the problem and how you fixed it, or maybe you never fixed it, right? Maybe it was just so hard you couldn't figure it out, but tell me what you did. Okay, the reason I ask that is if a person does not have a story about that. Like if their story is, well, I wrote a program one time, it wasn't working, so I asked the person next to me, they didn't know, I asked the TA told me what to do. That's not scalable, right? Like a person like that cannot be used in a company or as a grad student. If instead the person has a very interesting story, right? Like, well, I had this complex problem and I tried this and I tried this, and they show a systematic approach. That's a mindset and a skill set that is going to do them a lot of favors in their career. And that's a person I'd much rather hire as an engineer or as an employee. Okay, so you want to get good at this. So today we're going to talk about some mindsets that give you a systematic approach to debugging. These are kind of recipes that you can try to use. And then we're going to go through and debug a milestone 1 function. So you can see, well, exactly how do we do that with the tools that you have in this course. And that's going to be, pay close attention to that because you will have bugs in your project and you want to know, how do I do these things? And then time permitting, we'll basically have you try debugging a little program I'm going to give you just as an exercise in applying some of these skills. Okay, so I'm going to talk about kind of 3 different models you can use to think about bugs in a program. And generally, you keep all these models in your head. They're just help guide how you're looking at things. Okay, so one of these models is called the infection model. So this comes from the fact that software systems are causal. So in other words, later operations depend on earlier values, right? They don't depend on later values. There's no time travel. So when you have a program and it has lots of state. So this is basically representing a bunch of variables, and they all have data in them. So when you have a faulty operation, so you have some code in some subroutine that updates, one of your variables. So it updates some of your program state, and it was wrong. It updated it to the wrong value. Now, if you're lucky, you immediately get a crash, okay? Or there's a test that's testing that exact value, and it fails right there.
Hi, sorry to interrupt you, class. I'm calling from the tech team.
What? Yeah, that was weird. There's like predictive tech support. Tech support is phoning me thinking that I'm going to have a problem. And that made me really nervous. I just said the world is causal, and I actually now have tech support calling me in advance and having a problem. So
sorry, I just want to advise your OCCS recording for this room.
Yeah.
You have to enlarge the preview image.
Okay, that's okay. I've got another recording technique going on too.
Okay, that's fine. Sorry for interrupting.
No problem. Okay, so your easier debugging problems are when you detect the flaw right near where it corrupts your state, and sometimes that happens. Like you go outside of the bounds of an array and you get an immediate seg fault. That's actually good, but maybe you don't get that. You go outside the bounds of an array and you have just corrupted some of your program state, but nothing obvious happens. But now the program keeps running, and basically other variables are wrong because they're depending on this incorrect variable. So basically the infection is spreading. More of the program state is wrong. And at some point, you can tell, like the program crashes, it prints something that's obviously wrong. The test checks, did it get the right answer? And it says, well, no, the output's not correct. So you have a failure, but you have to remember that failure might come from code right around where that variable was updated, but it might have come from a significantly earlier update, and that's going to actually be harder to correct. Okay, so that's one thing to keep in mind, right? Where's the root cause? Might be back in time a bit. Another algorithm or technique to keep in mind is called the wolf fence algorithm, and so the name comes from how do you find a wolf in Alaska? So some wolf is howling, and I want to find it in this giant state. And all I can do is I can build a fence, and I can listen and see if the wolf is on one side or the other of the fence. Okay, so I build a fence down the middle of Alaska, listen, and it turns out it's the western side. So I try again, build another fence, listen, turns out that it's in the top side, north side. Keep doing this, and I keep dividing up the space, and eventually I have a small area left, and that's where my wolf is. So it's a divide and conquer approach, and you can do this in a program as well. You can try to determine this part of the program is correct. I looked at its outputs, and it got the right answer. So I can kind of eliminate all the code that computed that from consideration. And finding the root cause of a failure is hard. So I have a problem. I have an observed failure. I failed at some test. You're trying to figure out why did this happen, and you're trying to be efficient. So there's some cleverness to this. How do I eliminate possibilities quickly? So let's take, for example, this root failure, this failure that I've observed. I might go and check, well, what are all the variables that could affect that output? And I go back to some earlier point in the program and I check them, and I see, are they correct? And if they are correct, I can say, well, all the code that ran before that is okay. So maybe in your milestone one, this might be that you verify the load map data that you're using is in fact correct. And if you verify that, okay, I can ignore all that. It's going to be in the other code that returns data when you're called by our tests. I could also basically use the wolf fence algorithm to say, well, this part of the code doesn't even produce outputs, doesn't even produce variables that will affect this failure. So I can eliminate that. So I'm basically employing the wolf fence algorithm to eliminate large parts of my program from consideration and kind of dial in on a smaller area. Okay, so once I've eliminated a bunch of the program, I start tracing back. So maybe I look carefully at the code that produces this variable. Maybe I watch the debugger execute and I see, okay, actually did the right thing, but there were a couple of inputs to it, right? There's an input here, there's an input here. I go back, I watch that code execute in the debugger to see, did I do that correctly? And I eventually figure out this is the flaw, right? When I watch this code execute, it was okay. When I watch this code execute, that's the variable that was wrong. Okay, so I'm using the wolf fence algorithm to eliminate parts of my program from consideration. Maybe they don't produce things that are relevant, or I verified their output is correct. And I'm also backtracking, checking the code in the debugger and the state updates in the debugger from the output, from the failure back through the things that it was building upon. Okay, so the last thing to keep in mind is that you are a detective. You're trying to employ a scientific debugging method. So you observe the program, it's failing somehow. You look at the output, you look at maybe the program state in a debugger, and you form some hypothesis. I think I'm corrupting memory. Maybe that's your hypothesis. You think, well, okay, if that's my hypothesis, what would happen with this test case? Would this explain it? And you perform a controlled experiment. Maybe you actually go look at that variable, you print it out or watch it in the debugger. Maybe you do another test case that checks a simpler case that should trigger the same bug, and you see what happens. If exactly what you predicted happens, then you go, okay, that seems like it's the problem. If what you predicted would happen, if this was the root cause, doesn't happen, you say, okay, I got to throw that hypothesis out, I try another one. And you are trying to come up with hypotheses that are likely, but also ones that you can test pretty quickly. If you've got an idea, I could check. So for example, here we're saying we've got a seg fault. Maybe it's caused by going out of bounds. Maybe I'll run that in the debugger and I can actually just watch if I go out of bounds. So this is a hypothesis that I could check pretty quickly. You prefer hypotheses you can check quickly versus ones that are going to be really hard for you to figure out, how do I check that? I might have to write a whole bunch of code to check that. So even you prefer more likely hypotheses and ones that you can quickly check, because you're trying to minimize the amount of time it takes you to find the root cause. So both those things help you. Okay, so that's kind of overarching principles. Just keep those in mind. But you can see this is kind of a complex thing. Like none of these are like exact recipes of do this, do that. So let's go do this on a real case to make it a little more concrete. So let me bring up. Okay, so I am going to bring up VS Code by popular demand. If it doesn't work for me at all, I'll switch to NetBeans. So it's not very different. So basically all IDEs work pretty similarly. It's just exactly where they put the buttons tend to vary a bit. Okay, so I want to start VS Code. I type code, and you want to start it for the fewest problems from the same directory where the make file is. So this is like the root file. I'm in the root directory of my project. This is basically like your mapper project. So I'll go code dot, and it started up, and it should have, let me see, I might zoom out a little so I can see a little more. Yeah, is that still visible or not? If I make it too small, it starts hiding half of the icons on the screen. Okay, so here's my IDE. Let me hide these meeting controls again. Okay. And actually, even before I do that, okay, maybe what I'll do is I'll use that to show you just a bit of code. And actually, let's go back here for a second. Because I kind of want to remind you of where we were last week. So before I do this debugging demo, I'm going to quickly take a look here. Let me quickly check something. Okay. Okay, so now I do want to show you a couple slides. I want to make sure I didn't give you the answer of the debug before I went any further. Okay, so remember the function we wrote last week? It was one of your milestone one functions. It was find street segments of intersection. We passed in an integer ID of an intersection, so maybe 232, and you were supposed to make a vector of the street segment IDs, so a bunch of integers that connected to that intersection. So in this case, we should make a vector with 3 numbers in it, and those should be the 3 numbers. So everybody remember this? Okay, this is the one milestone function, one function everybody should get right. Okay, so, and we said to make it fast enough, we're gonna actually have to preload all the data. So for every single intersection, we're gonna preload what street segments connect to it. So we're gonna make a vector of vectors. So our first dimension, so we call it intersection street segments. We got our first dimension, and if we index into the first dimension, each entry is itself a vector. Okay, so this is the data for intersection 0. And intersection 0, let's say it has 3 street segments. So we'd have a vector of size 3, and it would have those 3 numbers in it. Intersection of 1, maybe there are 5 street segments, so it has a vector of length 5, the 5 numbers that are those street segments, and so on and so forth. So it's kind of like a 2D array, but it's kind of a ragged array, right? We can have a different length of vector for every single intersection. Does that make sense? Okay, and this, to refer to this vector, well, it's a lot like a 2D array. We can refer to that as intersection street segments Okay, so if I take intersection street segments of 0, let me erase this, that is going to refer to this entire vector. If I said intersection street segments of 0 and then of 1, that would refer to this number. Does that make sense? So just like a 2D array. Okay, we wrote this code, and here it is. Most of our code is in load map. So this is load intersection street segments. It's a helper function for load map. When the load map gets called before anything else. Your load map in milestone 1 can get long, so you should be writing helper functions. Your TA is going to be looking for style marks that you don't write really long functions. So in your load map, you should be thinking of writing code like this. Okay, so this is going to load up the data I need for one particular thing, and my load map is going to call a bunch of these helper functions. Okay, so remember what we did. We're basically saying, give me the number of intersections. I'm saying I want to load up this intersection street segments, which is a global variable. And what I'm going to do is I'm going to go through for every single intersection. I'm going to ask how many street segments hit that intersection and get that from one of our API calls. And then I'm going to go through, say I get told there are 3 street segments that hit intersection 0. I'm going to go through and I'm going to ask what's the street segment information for each one of them? Well, what is the ID? Sorry, what is the street segment ID for each one of those? And we have an API function that gives you that. And then I'm going to store it, right? I'm memorizing it. So this was for, say, intersection 0. I should push this back to the vector that goes with intersection 0. Okay, after I've gone through intersection 0, I'm going to increment the intersection number. I'm going to go through for intersection 1. I'm going to do the same thing. I'm going to keep going through about 190,000 intersections. At the end of that, I got 190,000 vectors. Each of them gives the street segments for one intersection. Okay, is everybody with me? Does this make sense? So it's kind of like I filled a 2D array. It's just a bit better than a 2D array. My function that gets called by our unit tests is now very simple, right? It basically, we told you what has to be called. Our tests are going to call a function called find street segments of intersection. That's what it's called in the header file. We pass you an intersection ID. You're going to take that intersection ID and you're just going to look up the answer in the global variable and return it. So this part is super simple, right? Just return the vector. Most of the work is being done in load map, where it's basically yeah, for every single intersection, working out that answer in advance and storing it in this two-dimensional vector structure. Everybody got it, okay? So I've written this code, I'm very proud of it. I'm gonna go and let's see if we can run it. Okay, so I just started VS Code, let's bring it up. Click up here, that's the Explorer, and I can see my source code. You write your source code or almost all your source code for this project in libstreetmap. All the code under there gets turned into that library that we talked about. And m1.cpp is where I chose to write this function, okay? So I go into m1.cpp, let's get rid of this, and look at what I've written. Okay, so I've got some global variables. I should comment global variables. Okay, so notice it says I got global data for vast APIs, I load them in load map, I clear them in close map, everything else should only read them. I give it a fairly long name, so I'm calling it intersection street. Let me make this a bit bigger. Intersection street segments. So you should follow this kind of commenting, right? Global variables are important, they should have long names, you should have a comment saying what they do. Then I say, okay, here are my helper function declarations. And I've got one. Got a helper function to load that one global variable that the intersection street segments function is going to need, or find street segments of intersection is going to need. And then I say, okay, I've got my, okay, these are my declarations. So I'm basically declaring helper functions that are only going to be used inside this file. And then I've got my actual function definitions. So the body of the function. And load map. Okay, so load map, again, we're going to call that in our test before we call any of your other functions. You have to at least load the data that our API needs. Okay, so for the function that we've written, we need data from the streets database API. We can't get that until we call load streets database bit. So I got to call it, and the load map is helpfully past the name of the file. So I'm just going to call it, okay? So I've loaded up the API. I've already figured out last week that it wasn't fast enough if I just call that API all the time when you ask me what are the street segments connected to this intersection. So I'm preloading some more data. I'm using my nice helper function to do that. And basically, if you read the comments in m1.h, it also tells you if load map fails, it should return false. So there's a little bit of code returning true or false here. Okay, so here's my helper function, which I just showed you. This loads up that 2D vector. And here's my function that actually returns the street segment of an intersection. Wait a second, did that actually just show me this? I think the IntelliSense might have started working now. Part of the reason I'm slightly frazzled is I was spending the last half hour before this tutorial trying to make IntelliSense work, and I think when I came here, it suddenly started working again. So that's odd. So I have a debugging problem when I go back. I have to figure out why is that happening. Yes, it's now actually, this is super baffling because I swear it was broken and now it fixed itself. But that's good news. Okay, so here's our function that, our test call. And again, it's very simple, just returns an intersection ID. I've only written that one function. So I've stubbed out all the other functions so that everything will compile, but they're obviously going to fail. Okay, so I'm going to shrink this down because I like to do some things with the command line. So I'm just going to make sure I've got the latest code. Okay, and I do, but I'm just going to make sure I know what what build I have. So I'm going to say make conf equals release. Doesn't have to be release, but the release build is the fastest. And I'm going to run exercise. Okay, so I just tell it the milestone number and it's running. And I got a bunch of tests. It's already failed. So I'm going to go back and look at what these tests are. There's already a lot of output. And lots of output is bad news from a test, because again, the convention is don't say anything if it passes, except it passed. And if it fails, you say exactly what failed. Okay, so we've grouped our tests into a bunch of different test suites. And the first one is testing the functionality of intersection-related functions. That's actually where the one function that I've written is going to be called. Okay, so I already know that. If I didn't know that, I could go look at the source code of our tests, which we tell you where they are in the milestone 1 handout. Okay, so the very first test, well, and this is actually telling you where it is too. So this is exactly where our tests are. And it says there's a failure in intersection street segments. If I go look at this code, I'll see that's the one that's calling my find street segments of intersection. And it says unhandled exception, test crashed. And then there are other tests. Okay, so basically it goes on to failure indirectly connected. This is actually a different function. Okay, I haven't written it. This is the is directly connected function. It's failing because I'm getting the wrong answer. Well, I just always return no. So if you look at my functions, I stub them out. So I expect this to fail, but this one I wrote and I thought it should work. Okay, so based on this message, there's not much here. What does unhandled exception mean? And so my only output is that I failed with an unhandled exception. So it's a bit vague, but it does tell me basically the test crashed. So I wasn't returning the wrong values. Like actually just the program crashed. So it was really wrong. So, okay, now I want to try to get more information quickly. I could go and stare at the code. I'm not going to do that because often people do that. They stare at the code for a long time, just going, maybe I can figure it out. You can go look at the code really quickly, but don't stare at it for very long. You want to get more information if you can't immediately see the problem. What do you think I should do to try to get more information? Because so far this is pretty vague. It says unhandled exception, test crashed. I don't know what to do. So what do you think? And basically I want to do things that are fast. Maybe I can do something that's going to give me some more information. I can do it really easily. That's good, because maybe I can find the bug faster that way. Yeah, what do you think? So I can run debug check, and that's actually exactly what I'm going to do, because it's pretty fast, right? It's actually faster than me. For example, I could put print statements all over the program. That could take me a really long time. I don't want to do that. It's actually the worst. So you do use print statements sometimes, but that's not your immediate thing to do. So I'm going to go down here. To do that, I say make clean. So just make sure that my old build is gone. And I just say make conf equals debug check. And I could do this through the IDE as well, but I like doing this through the command line. I find it faster. Okay, so it's built it. And now I just run ece297 exercise again. Before I do that, I'm going to show you a trick that can make you more productive. So all of our programs take this -h argument to give you help on how you can call them. Okay, so I just asked for help on ece297 exercise. And it says it has a few options that I can send in. I can send in a list testers option. I can send in a run tester option. Okay, actually I can also send in a debug tester option. And then I must give it a milestone number. That's what this means. Things in brackets are optional. Something that's not in brackets isn't. So milestone number is 1. So I know how to do this. Okay, so it says there is a milestone number. You got to pass that in. And then you got these optional arguments. So list testers basically is going to tell me the names of all the test groups or test suites that we have for this milestone. And then run tester, we can actually, instead of running all the tests, we can say just run this one. Okay, now I'm trying to debug the intersection test, so I'd actually prefer just to run it, because I don't want to I know none of the other tests are going to work. So I don't want to wait for them to run, and I don't want to wade through all their output. Okay, so let's, okay, so ece297 exercise 1 -- list testers. Okay, and I don't need to memorize this. The -h will tell me it. Okay, so this has told me the names of how did we group these tests. And I know that this is an intersection related test. It's going to be in the very first one. And it's functionality that I'm failing. And my test just doesn't work. I don't even need to check the performance ones yet because, well, I don't have to worry about being too slow. It just doesn't work. If you didn't know which test suite it was in, you can go to that directory that's in the milestone 1 handout where all our tests are. And you could basically look through it, seeing which one calls this function. Okay, so I'm going to now, so from now on, I'm going to just run the intersection tests. Now, I could type this whole name. So I could type all of that, and that would be fine. But I can also use shorthand. So I'm going to put a little single quote star func underscore inter star. Okay, does everybody know what star means when you use it in a command line like this? What's it mean?
What is the involved that specific one we need that?
Yeah, it basically matches any sequence of characters. Okay, so by putting a star at the front, I'm saying anything, then it has to have func inter, then anything. I put it in single quotes because that basically makes the command shell understand that this is like wildcarded. So this just saves me typing, right? So it's useful to know things like how to use wildcards because I can type less. But if I didn't know this, if I type that whole name, it'll be fine. Okay, so I'm going to run that. Okay, so I built the debug check build, and now I'm running just the intersection tests. Okay, and it failed. And I'm going to go back and I'm going to read this output carefully. Okay, so it's running the test. So debug check found a problem. And what debug check does is when it finds a problem, it kills your program and it tells you why. So let's look at what it found. Okay, so it basically says it's in the vector function. Yeah, I didn't write vector, right? This is part of the standard library. And it actually tells me, you know, it's way down in some low-level vector code. And I didn't write any of that code. The one that I recognize is it basically says it's operator square bracket. Okay, so what I can get from this part of the message is it's a vector and it's a square bracket operator. And then it tells me a little more user-friendly message. It says, I'm attempting to subscript, square bracket operator, a container with an out-of-bound index, and the index I'm trying to use is number 1, but the container only has one element. Okay, and I know what kind of container it is because I can see that it's actually in the vector code. Okay, so it's a vector, I'm trying to index entry 1, it only has one element. Can I index entry 1 in a vector that only has one element? Am I allowed to do that? What do you think? No, right? So you only have element 0. I shouldn't have indexed element 1. So, and it tells me the memory address of this, which I'm not going to do much with, right? Because I don't know where this is in memory. It also gives me a little more information. It basically says, okay, the program's been aborted, likely due to memory corruption, and backdoor unhandled exception. Okay, so the program's dead. Okay, so that gives me some useful information. It's a vector, we're going out of bounds. But I still don't quite know what to do. I could go look at my code, I know there are vectors in there, but I want to get some more information quickly. So I'm going to run valgrind. Okay, valgrind's also a fast checker, and it's not compatible with debug check. So I'm going to make clean. I'm going to make the debug configuration so that I can run valgrind now. Let me make sure I got that correct. Okay, so I rebuilt it in debug. And now I want to debug the unit test. Okay, so the unit test, to debug the unit test, to run valgrind on the unit test, like this exact unit test, I want to bring over the test code, which we wrote, and you can see, but I now want to bring it into my project so that I can actually compile it right in my project, run it through the debugger, run it through valgrind. Okay, so ece297 exercise is your friend again. Let's do the -h. And notice there's another option called debug tester. Okay, so basically this grabs whatever test you asked for, takes a copy of it from our shared directory and actually sticks it into your source tree so that you can now compile it so you can run valgrind on it, and you could also run it in the debugger. Okay, so we don't want you to have to copy it by hand, so we just did this for you. Okay, so it's debug tester, and I know it's the intersection tests. So I remember it was func, inter, that was in the name, so I do that. Okay, so it tells me what it's done. It basically says it's putting the tests in libstreetmap. That's again your library, but your code is going in /source. That's your main code. It's put it in /test. And you might have had tests in there already, so it doesn't want to just overwrite them. So it moved them into a directory called .old tests in case there's something you'd like to get back later. And then it tells you exactly what to do, right? Compile it in your IDE, and you want to compile and run the unit test configurations. And it even tells you how to run Valgrind. So it says to run Valgrind, use the following command. So it tells me exactly what to do. And I'm going to copy this. You can look at it. Basically, what this is just saying run Valgrind. This is the full path to Valgrind. It says Valgrind actually has multiple tools in it. So it's saying, how do we want to run Valgrind? We want to run the memory checking tool. We want it to check for memory leaks as well. So we're basically giving Valgrind some options that we found are going to give you more useful output. And then the last thing, this suppressions. Most libraries have a few memory leaks in them that are not a big problem. Like they allocate some memory just a little bit and they never bother to free it. So Valgrind by default will complain about that, but you guys can't fix it. So it's kind of distracting, it's kind of annoying. And it's not a big problem, right? We've already validated these are just in the library and they're not going to cause major problems. So memory leaks are not nearly as bad as memory corruption. Memory corruption is really bad, but a small memory leak is not a huge deal. So we have suppression files, which basically means we're telling Valgrind, don't report this because we don't want it polluting your output. That's what these other options here are. That's just for your information. You can basically just paste the command in. Okay, so I just copied that, I pasted it, I'm going to run it. And let's see. What did it do? It says no to, okay, maybe I need to build this again. Because it didn't do very much. Let's see, what is it doing here? Command test loop street map. Okay, let's see. Oh, okay, I forgot to build. So it ran right away because I hadn't built anything very useful. Okay, so now I built the code again. I run that Valgrind command. And now it's actually doing something useful. Basically, it ended right away because I had actually built the unit test after I completed over. So I have to remember to build them. Okay, so Valgrind slows your program down a lot. Actually slows it down even more than debug checks. This is going to take a little while. But we'll see, does it give us some additional useful information? Valgrind is also a little different. Debug check, as soon as it finds an error, it kills your program. Valgrind keeps going. So from Valgrind, you might get a lot of errors. You want to go back and probably look at the first one, right? You might have the same error repeated many, many times. That's okay. Don't get confused by that. Okay, so in a few minutes, Valgrind is going to finish running, and then we'll go look at its output to see if we can tell anything useful about it. Okay, so it's done. Okay, so a bunch of these, if I look at this output, let me look at it carefully. Okay, so let me go back to the start. I'll do exactly what I told you guys you should do. And there's a fair amount of output. But basically, it is telling me, here's an error, okay? Here's the start of an error. So it says there's an invalid write of size 8. Okay, what does invalid write mean? Any ideas? Yeah.
We try to write something in a memory that does not is not partitional.
Right, so writing outside memory that we've actually allocated. Typically, this is an array or a vector, would be a common thing that we've gone outside its bounds. And it's telling us, this may or may not help us, that the size of the write we were doing was 8 bytes. So whatever data, the amount of data we were trying to write was 8 bytes. It tells us where did this happen? And this is a call stack. Okay, so it tells us the last function was in vector. Okay, so it's in the standard library. It's some kind of internal function. The function before that was pushback. Okay, so it's vector pushback. It's causing the problems. And that was called from load intersection street segments, line 65 of m1.cpp. Okay, so I know what line of code in my program, it was calling pushback and it was going, something bad was happening, right? It was writing over memory that it didn't own. So this is bad. And then you'll see this call stack keeps going. You don't really care after this. The rest of this call stack is essentially telling you like what are all the functions in our tests that gradually call each other and eventually get to you. You don't really care. Okay, that's all code we wrote. The bug is going to be here. This is your code. So basically it says your error, you are calling pushback on line 65, and that's a problem. And how you got to that call is you called load intersection street segments from load map. So it was load map, line 47, called load intersection street segments, which on line 65 called pushback, and that pushback was bad, right? You shouldn't have done it. And then, as I said, there's a whole bunch of stuff here about how did we call you, but you don't care. Let's see. The other thing that can be helpful here, yes, there's a long call stack, and okay, the other part of this message that can be helpful, so that tells me where did I do the bad right. It also is telling me where was the I was writing right after a block of memory that happens to be of size 24 bytes that I actually did allocate. Okay, so there is a block of memory near where you were trying to write. You were trying to write right after it. And that memory was created by operator new, and operator new was called by vector and a bunch of vector functions. And that vector function was called by, let's see, the vector function was pushback. Okay, so this memory was allocated by vector pushback, and that was called from line 58 of m1.cpp. Okay, so the pushback on line 65 is bad, and it was trying to write to memory it doesn't own, and it almost was writing to memory, it was writing near memory that was allocated on line 58 of m1.cpp. So I'm going to bring up Visual Studio now. So basically, remember those numbers. So line 65 is the one where it says you're trying to write to memory you don't own. And if I look at the call stack carefully, it was pushback. So this is the line. That's the line that is making me crash. It is a vector. And remember, debug check told me that I'm trying to write into entry 1, and there's only entry 0. Okay, so that kind of lines up with what I'm seeing here. It also told me where this was allocated. It told me that the memory I'm writing, on line 58, allocated a block of memory that's right near where I'm writing. Okay, so this all kind of lines up. It says, well, this pushback to this data structure is not good. I allocated the data structure here, and I tried to update it here, and that resulted in an illegal memory write. And I even know the indexes, right? From the debug check, I know that it's index 1 that's a problem, because this only has this vector has a size of 0. So I shouldn't have used index 1. So at this point, I could stare at the code, and I'm down to kind of a very small number of lines of code that are going to be my most likely problem. So I might be able to figure it out. But let's say I can't figure it out. Like I look at this and nothing seems obviously wrong, so I don't quite know what to do. So, okay, so what should I do next? Call the TA, post on Piazza. No, don't do those, right? You can do that, but that should not be like first thing. I've got like a hotkey for Piazza, right? So don't do that. Try to sort it out first. Because if you go to a job interview and you're looking for PEY and they ask you a programming question, you say, it's fine, I'm just going to bring up Piazza and ask my TA if he or she can do this, right? So it's not a good answer. Okay, so what should I do next? What's in our toolbox? Yeah.
Give you a breakpoint to line 47, I add TA, and then try to see what is actually happening.
Yeah, that's exactly right. So what I should do now is, okay, I know roughly where it is, but I still can't figure it out. I got to watch this execute. So I'm going to click on these makefile tools here. And this is another strange thing about VS Code. So you have to basically tell it, what configuration do I want to build? Okay, so I'm going to build unit test debug. The build target. Okay, so for unit test debug, it is this one. Let's see, where's test libstream map? I have lots of files here. Let me just find the right one. Well, I know what it is. ./test libstreetmap. All right, I'll look for it here. Okay, so basically telling it I want to debug the unit tests. So make the unit test debug configuration. That's what I want to build. I have to tell it the name of the program that I'm trying to build. And let's see. I'm just going through this carefully to get the right one. This is it. Okay, so when in milestone 2, you're actually going to run your sort of real program. And that's called mapper. That's like your main program. But our unit tests don't run mapper. They run a program called test libstreetmap. Test libstreetmap just talks to your libstreetmap library, where most of your functionality is, and just exercises the functions. Okay, so it is like a different program. It's got like a different main function, right? That's what unit tests are. And it's not a very interesting main function. The main function just runs a bunch of tests by calling your libstreetmap functions. So that's the one I want to use here. So I make my build target that. And then I'm going to make my launch target the same. Okay, test libstreetmap. Okay, so what does all this mean? Basically, I want to build the unit tests in debug mode. The program that should be built is called test libstreetmap, and the program that you should run when I invoke the debugger is called test libstreetmap. Right? They're going to be the same. Once I set this up once, right? If you followed the instructions in the VS Code Quick Start, this is already all set up because you clicked it all in, and you can just click on them and choose one, right? So you only have to do this entry once. Okay, so now that I've done that, I'm going to click on these. I'm going to build the tool. First, I'm going to make sure. I'm going to basically get rid of any old build because I just want to make sure I know what I'm doing. So I got rid of any old build by saying makefile build clean. Build clean means get rid of an old build. Okay, and I did that just out of paranoia. And now I'm going to click this button, which actually builds it. Okay, and let's see. Okay, now I'm going to run the program. So I already know from running ece297 exercise that this should fail. So I'm just going to click the triangle to run it. So I'm not debugging it yet. I just want to see that it actually does fail the same way as it did when I ran ece297 exercise. And it does, right? So I get the same error I originally got from ece297 exercise. Basically, there's an unhandled exception when I run this intersection street segments test. There also are a bunch of other errors coming from other functions in this test suite, which I don't care about. So I go look at my m1.cpp. So I go up here, click on the file explorer. Let's look at m1.cpp. You can see all the other functions I've just stubbed out, right? They all return empty vectors, they return 0, etc. So none of them are going to work. So I don't really want to be looking at these failures over and over again. So I'm going to go change the tests. So if I go into tests, let's just see if there's anything in old tests. I'm going to actually remove old tests too. I had some old tests lying around. I'm just going to get rid of that. All right. Okay, so if I look inside this tests directory, you're going to see a few things. Okay, so you see a file called test driver. We're going to talk about this in lecture in maybe on Thursday, maybe next Tuesday. This is the main program for the unit tests. So notice there is a main function. So this is where the program is going to start running. And it basically just says run all the tests. And then so that's pretty boring. There's a utility file here that we wrote. You don't really understand what's in it, but basically this got copied over. It has a bunch of helper functions that we're using. And then the actual test that you're running is here. in this M1 func intersections Toronto, Canada, public.cpp. So I copied over the tests. And if I look at this, you don't need to understand all of this, but basically it says this is the whole thing is a test suite. Okay. We do some setup. We don't care too much about that. And then everything after this text fixture. So a test fixture basically sets up the conditions for a group of related tests. And then we have a bunch of tests. Okay, so this is the name of the test, intersection street segments. And we basically have a vector of expected data. Here we say the expected data is a vector of length 3 with the numbers 7, 140, and 147 in it. And then we compare that to the result of calling your find street segments of intersection with intersection 13. So we've already worked out that this is the answer for intersection 13. And we're checking that the vector you return is exactly equal to this vector. If it's equal, you pass. If it's not equal, you fail. Does that make sense? And we don't just check one intersection, then we go do the same thing for intersection 34,725. And that returns different street segments, and so on. Okay, so there's a whole bunch of cases in here that we're going to call one after the other. If it is equal, there's no output. If it's not equal, you get an error message. Does that make sense to everybody? Why do you think the sorted is just a helper function that sorts the vector? Why do you think we do that? It's kind of an aside, but why do we sort it? So we're taking the return value of your function, which is a bunch of street segments, and we're sorting it, and then we're comparing it to the vector that we've already computed. Is it important that we sort it? Yeah.
Is it faster in terms of optimal?
No, it's basically when you write tests, you have to be careful that you're testing exactly what you want and no more. So if we didn't sort this, you would have to return a vector in the exact same order that we put it in here. But what if you just wrote your loop the opposite way or did it in some different way? Your answer basically meets our specification because we didn't tell you any particular order for these street segments. We actually don't want to tell you any particular order, or it doesn't really make sense. But then we need to make sure that our test will pass no matter what order you return these in. And an easy way to do that is we'll take whatever you return and sort it, and all our expected answers are already sorted. Does that make sense? We do this for all sorts of things. If you actually read these unit tests, you'll find that we'll add tolerance. If we ask you what's the distance, what is the length of a street segment, we don't check is it exactly equal to some number. We check is it within 1%, like things like this. So we've taken some care. You may find a bug in this still, but hopefully not. We've taken some care that no matter how you write your program, you will pass our tests if you do it in the right way. And you have to be careful. It's easy to write tests that are overly strict. That you have to write it exactly the way we were thinking or you fail. So we didn't do that. Okay, so this is actually, though, testing the function we want. Find street segments of intersection. So I want all these tests, right? That's my function that I've done, and I want to check it. And there's a bunch of lines of this. So it checks a whole bunch of inputs and outputs. Okay, and then after that, we see a new test fixture. These are all basically predefined classes and macros and stuff that the unit test library gives us. So if you go, I don't know what a test fixture is, it's fine. If you go read the unit test quick start guide, it'll tell you, well, what is that? But basically it helps us shorten our code, right? People usually use libraries to help them write unit tests. So we did that. Okay, this is the function directly connected. It's another function you have to write. And you'll see here we're checking intersections are directly connected. And we pass in a pair of intersections, and we check whether you return true or false. And we already know what the right answer is. I don't want to check this because I didn't write this. So I'm going to highlight all that. And then there's actually another test fixture for find angle between street segments. I haven't written that. So I'm just going to delete all that. Okay, so I deleted both those. My file got shorter. I'm going to rebuild this. Hopefully it will rebuild. Oh, actually, one thing. If I rebuild from the UI, it'll probably be fine. This dot means the file has been modified and it's not saved to disk yet. Okay, so if I rebuild in the IDE, it knows it should save it to disk. So that should have saved it to disk, but I generally just hit Control-S all the time to save it. If you went out and typed at the command line make right now, you wouldn't actually get the latest code because you haven't saved it. So don't forget to save don't forget to save your files. I hear students in the labs often are forgetting to save their files and wondering why when I go out to the command line and type build or make, nothing changes. It's got to be on the disk. Okay, so I just rebuilt that. I'm going to run it again. And what do I get? Let's see. Yeah, this is a strange thing that happened to me before too. So Visual Studio Code does slightly odd things with make files. So it's still running the old code. It hasn't fully rebuilt it. So what I'm going to do, so I'm just going to go out here and I'm going to rebuild it. Okay, so I'm going to rebuild the debug configuration. And now I'm going to run this again. And that's interesting. Okay, so it's got some old code lying around. Let me clean this. Okay, so let me run that. And that is odd. Why does it keep doing that? Okay, so for inexplicable reasons, it's still running the tests that I deleted. And I got this before, and I really can't figure out why it's doing that. Okay, so that looks better. Let's try this again. All right, let's try that. Huh, okay. I've got something very strange going on in my code path. Okay. Okay, let's see what happened here. Okay, so we're gonna take a break for a minute. Basically, I deleted all the tests I don't want. And when I run the actual test executable, test libstreetmap, you can see now I just get shorter output, right? It's only the one test that's left. Now, inexplicably, Visual Studio Code is still running an old version of my code. So we can take a break till 5:20, and I'm gonna try to figure out why it's running an old version of my code, because somewhere it is stashed like a build, which I've gotten rid of at the command line, but somehow it's still running an old one. So this is why I like command lines sometimes, because I know exactly what is happening. I've deleted the old build and I'm running it. Visual Studio somehow has managed to connect to an old one. But anyway, let's take a break to 5:20. I'm going to figure out why Visual Studio is doing that. Yeah.
Is it wiser to like use the terminal itself instead of the VS Code?
I mean, I'm going to show you the debugger in VS Code. It's easier to watch a debugger run. So I would use an IDE to invoke the debugger. You can invoke it from the command line too, but most people would prefer to run a debugger inside it. VS Code inexplicably doesn't work as well with makefiles as basically every other IDE in existence. So I don't know why that is, but I'm going to try to figure out why it didn't properly rebuild the project. It's somehow using an old version of the code or an old executable. So I guess be aware of that. If you kind of go up, but I've changed the code, I don't know why it hasn't rebuilt it, go up to the command line, rebuild it, run it there, and that'll confirm, yeah, this is what the latest code does. Does that make sense? But I'm gonna go figure out like why is it not rebuilding this when I do it from the IDE? It says it's rebuilding it, but it clearly is not fully rebuilding it because it's still got my old code in it. And I just confirmed from the command line, it's gone, right? I look at it on disk, it's gone. I build it here, I run it, it's gone. So I'm going to debug this. This is a mystery to me too. So let's talk again at 5:20. Okay, we are back, and I figured it out, and it appears I'm an idiot. Okay, let me make sure we're recording again. Okay, so I do not normally use the command terminal in VS Code. So I'm not used to a terminal that puts the new output at the bottom and doesn't move you down there. So the reason I wasn't seeing the proper output is I was looking at the old part of the terminal, okay? So once I scrolled way down to the bottom, it's actually doing exactly what you'd expect. So I basically changed the code so that I got rid of all the tests except the one we care about. And now when I run the code from in Visual Studio or from the command line, I get the same answer. It basically says, I failed the test, I got an unhandled exception, it crashed. Okay, so I've successfully brought over the test, deleted all the ones I don't care about, now I can run them. And the way I got that was, again, I just built it. Okay, so I'm building it, and now I basically type run, and I get the exact same thing I got from the command line, which is good. I was just confused by the fact it didn't scroll down to show me the new output. So, okay, so now I want to debug this though. So I don't want to just run it in the, I already know this, right? I know it crashes. I need to figure out more. So I click on this debug icon. So I'm not setting any breakpoints right now. I'm just gonna run it through the debugger. Okay, and sometimes it can be useful. Like if I didn't have it, I actually have a pretty good idea of where it fails, so I could set a breakpoint, but I just ran it through the debugger to see what happens. It says exception has occurred, segmentation fault. So we already talked about segmentation faults. It means we're accessing memory that the program doesn't even own. The operating system has killed us. So this all lines up with I'm doing something bad for memory. I can actually do something now though. Okay, so do you guys know what this is down in the lower right corner? So what is this down here? What's it called? I think you know. Right, so it's a call stack. So even though the program's dead, the program is dead, right? I have a seg fault, so I can't single step, I can't do any of that, but I can actually examine like the body, right? I can examine the state of the program, try to investigate the scene of the crime. So I'm gonna do that now, right? If I ran this program for quite a while and then it died, I might wanna look at this for a bit before I give up and run it again. So the call stack tells me I was in new. And let's see, let's make this a little bigger so I can see a bit more of the names. So, this is in the standard library. Okay, so new doesn't have a bug in it. That was called by the constructor. That was called by vector pushback. Okay, so vector pushback, let's double click on that. Still in the standard library, but at least I know it's vector pushback. Now this is getting into my code. So I double click on this, and now I'm in my load intersection street segments. Okay, so this lines up with what I found from the debug check build in Valgrind. Let's get rid of that text. Again, let's see. Let's hide that again. Okay, so let's make this go away so I have a little more room. And like that to go away too, but whatever. So anyway, this is the line that crashed. Intersection, street segments, pushback. So it kind of lines up with what I've been finding all along. I can actually look at the variables. So what is it telling me? I was going through this for loop. I crashed on this highlighted line. And I was on intersection 1. Okay, this kind of lines up with what I was told by the debug check build. I was trying to access a vector with an index of 1, and the vector only had 1 element in it. I can actually go and look at So the variables window shows me variables that the debugger thinks might be interesting, and intersections was actually kind of interesting. The number of segments of that intersection was 2. That seems okay. The number of intersections of the whole city was 194,000. That seems okay. So none of those look very suspicious. I can go here and I can actually even ask some more questions. Even though the program isn't running anymore, I can say, let's look at intersection, street, segments. Let's look at how many elements are in it. Okay, and it actually tells me the size of intersection street segments is 1. So it actually kind of lines up with what the debug check build told me. So I actually know what's going on now, or I have a pretty good idea. I'm accessing intersection 1, but the size of this vector, intersection street segments, is actually only 1. There's only entry 0. I could look at other things if I want. So let's see. So if I want to, I could basically say, let's look at intersection street segments of 0. Okay, so that's the value for intersection 0, and that should be a whole vector, and it is. That's not super interesting. Maybe I'll say, what is the size of it? And it says it's got 3, it has 3 things in it. Okay, so 3 street segments. That seems reasonable. So you can figure out a fair amount, even examining a program after it's dead. But maybe I still can't figure everything out. So I'm going to set a breakpoint. And I'm going to run this again. So I'm going to go back to, let's go back to the debugger here. Oops. And I'm going to set a breakpoint at the start of this function, maybe right there. Okay, so I just click in the margin to set a breakpoint, and I'm going to run GDB again. Okay, let's get rid of that. Let's go back to the let's see if I can figure out how to stop the let's go back there, and I want to stop the debugger. All right, anybody know how to get rid of this like pop-up, which appears to be blocking my debug controls? All right, let's go over here to the debugger settings and get rid of that. I want to go back to so I want to get my controls back for the launching the debugger, but I can't find them right now. Oh, that's a good idea. Oh, thank you. I was just trying to find an escape key that would make it go away. That was an easier way to do it. Okay, so let's stop the debugging. And let's make sure that I set a breakpoint. Okay, so I have a breakpoint there. I'm going to go back to the debug menu and I'll go back to the, whoops. Okay, let's launch the debugger. Okay, so I've run until I hit the breakpoint, and now I can basically use these keys. Does everybody know what all these keys do? Like step into, step over, etc. All right, so I'm going to basically go down here and watch what happens. And let's see. Let's bring up my debugging windows. So I got the right, what looks like a reasonable number of intersections. I do a push back. Whoops, I probably didn't want to step in. I'll come back out. Okay, so I'm going to step over these functions. I don't want to go inside the standard library functions, so I'm just going to step over these. And basically right now I'm on intersection 0. And as I'm stepping through, it seems to be working okay, right? So it's pushing back street segment IDs, and the street segment IDs that I'm getting seem reasonable. Okay, and then I go back to the top of this loop, and I get, I'm in intersection 1. I go in here, I get a street segment ID. It looks reasonable, it's ID 0. I try to push it back and I die. Okay, so now I've probably gotten around as much information as I can get from the debugger. What have I done wrong here? So at this point, I now need to kind of look carefully at the code. I need to think about what's happening. So let me go back up one level. Okay, so there's the code again. Let me get rid of this. Okay, so intersection 0 works, intersection 1 doesn't. What's the problem? Does anybody know what's going on? So I keep hitting this line of code. I'm crashing here. Debug check told me it's a problem of accessing something. I'm accessing a vector with index 1 and there's only 0 elements in it. And that's true. I actually asked what is the size of intersection street segments, and this whole vector only has 1 entry. So only intersection 0 has a valid entry. Nothing else does. So when I try to access intersection 1 with the square bracket operator, is the square bracket operator allowed to create new data? No, so it can't create new data, so that's the crash. So now I have to think, well, why did I get that, right? I asked how many intersections there are. It told me 194,000. I'm going to loop through them all, but I'm still getting this crash when I try to put something in intersection 1. So I've done something wrong here. Now I need to examine it carefully. So let's look at street segment. Let's look at, well, intersection street segments is a vector. It's a vector of vectors, okay? So if I want to go look at its declaration, this is its declaration, right? It's a global variable. Global variables are constructed when the program first starts. They're actually constructed before you even get into main. Am I calling a constructor here? Doesn't look like I'm calling a constructor. So I get the default constructor. The default constructor makes a 0 length vector. Okay, so what does it mean when you have a 0 length vector of vectors? Well, your first dimension has 0 length, right? So I've got nothing. When I come down here to my load intersection street segments function, I say intersection street segments push back, and I push back an empty vector, right? Street segment IDs is like a little vector that's going to hold my street segment IDs, and I push that back into my vector of vectors. That creates entry 0. Okay, entry 0 now there's one entry in this vector, and that itself is an empty vector in index 0. So the first vector exists. And when I go down here and I start putting data into that first vector, it all works, right? I can access entry 0 in my first dimension, and I can push back stuff into that vector because it exists. When I go to index 1 doesn't exist. My whole first dimension is only has size 1, okay? I try to access it and I crash. Does that make sense? Okay, so I need to fix this. So we finally kind of gotten down to, this is exactly where it went. We did this in a very slow and painful way because I wanted to show you all of the tools that you can use to debug issues like this. One last thing that can be useful, if you right click on a breakpoint, okay, let's say this didn't occur on intersection 1. Intersection 1, I could just set a breakpoint, step through a few times, I'll get to intersection 1. Let's say it happened on intersection 10,000. If that happens, I can do this. I can say edit breakpoint. Well, maybe what I would do first is, let me get rid of that. I might want to stop here, okay, if it was intersection 10,000, because I don't want to step through this loop 10,000 times. I can right click, I can edit the breakpoint, and I can say intersection equal, for example, 10,000, okay? So if I did that, now this breakpoint will only fire when the intersection is equal to 10,000. So it's called a conditional breakpoint. it can be helpful when you're going through a loop many, many times and you want to get to a later iteration. But I don't need that now because I know what to do. So let me get rid of this breakpoint. And let me get rid of this breakpoint. Okay, so I need to fix this. How can I fix this? There are a couple of ways. So I'm trying to create things with the square bracket operator. Not allowed to do that in a vector. What should I do? And I'll give you a chocolate bar if you come up with an answer to this that is even close to correct. What do you think? You're saying resize it? Yeah, so there are, so that's a good solution. So let me tell you first how you could do this with pushback. So the problem here is this pushback is only creating one entry in my first dimension. If I took this pushback and I put it inside the loop so that it was pushing back on this vector, the first dimension of the vector every time, I would be creating a new empty vector and I could fill it in. That would work. Okay, so I could move my pushback, but this happens so often that there's a convenient function to work with here. Let's see. So if I go to C++ reference.com, all right, I told you it would go here a lot. So I'm going to go to the containers library. I'm going to go to vector. And in vector, we have a list of all of its member functions. And one of those member functions is called resize. Let's see. Let's go down to the actual description of it. Oops, went too far. Okay, so this resize member function, if I know how many things I want to put in a vector, it can be convenient to just say, give me that many entries, rather than calling pushback over and over again. In this case, I know exactly how many entries I want in that first dimension of vector. I want like 194,000. I want the number of intersections. So you can call the resize function and you just tell it how many things do I want, and it'll just make them all for you, okay? So that's gonna make the first dimension of my vector. It will fill them in with empty vectors. There's a 2D vector, so it'll basically make me 194,000 entries, all of them default constructed, so that means empty vectors. But that's exactly what I would like in this code. So I'm gonna go back and type that in. And let's see, so the fix is pretty easy. I basically just changed this to resize, and I have to pass in the number of elements I want in this first dimension, which is num intersections. Let's see if any. All right, so I saved that. I'm going to build that. So I'll stop debugging. Okay, I'm clicking back over here on the Makefile tools. I'm going to rebuild it. And I'm confident, so I'm just going to run it. Okay, and now the run basically says success, one test passed. So remember that our tests tell you a bunch of information. If they fail, if they pass, they just tell you how many things passed. So I only have one test passed is good. This function now works. Okay, so we fixed our function. Any questions on that? Does it make sense? Okay, so I went through this kind of slowly and painfully, partly because I don't use Visual Studio Code that much. I use other IDs, and partly because I wanted you to remember exactly how to run all these commands to get our tests. Yeah?
Don't we need the pushback anymore?
I still have a pushback, so let me go back and look at the code. Okay, so let's see. Okay, so let's look at this code carefully. So this resize, two-dimensional vectors you have to kind of think about carefully. They're like 2D arrays. So this resize basically says, take my vector, intersection street segments, and this will make the first dimension. Okay, it'll make num intersections. All of those will be default constructed, which means they're empty vectors. Okay, then I still have this loop that goes through every single intersection in the city, asks how many street segments are connected to this intersection, and it pushes them all back into basically the subvectors, right? So it's basically getting the subvector, like the second dimension, associated with that intersection, and it's doing pushbacks to put the right data in. Okay, so the key difference here is the first index now exists. It has a subvector that is empty, and now I can push back to it. Does that make sense? Okay. Okay, so that's most of this tutorial. But what I'd like you to do for the last few minutes is team debugging activity. So switch the presenter settings. Okay, so I've made a little program that all it does is it sorts its command line arguments. So its name is argsort. So you call program argsort. You give it some command line arguments like 6, 1, and 3, and it'll print them out sorted. Give it bigger numbers, it prints out them out sorted too. Okay, here's the code. It's not super long. It's basically two things. The code on the left is the main function. Have you guys ever seen this? argc and argv. Do you know what that is? Okay, that's how in C and C++ you get arguments from the command line. Okay, so argc is the number of words that are typed on the command line, including the name of the program. Okay, so in this case, argc would have been 4. Okay, in this case, argc would have been 1, 2, 3, 4, 5, 6. And then argv is a C-style strings, right? Just character arrays. And it's an array of those character pointers. The number of basically goes from 0 to argc minus 1, and it gives you each one of those words. Okay, so it's pretty simple. What the code is trying to do is basically take this data from the command line, put it in a vector, so a vector of integers, and pass it to a sorting function called shell sort. Okay, what is shell sort? Shell sort is a sorting function that you haven't been taught. It's a sorting function that's kind of like quicksort. Quicksort divides things in 2, but this one divides them in 3, just to be unique, right? And you can see that whoever wrote this kind of didn't like long variable names, all right? So it's kind of a little annoying that the variable names are pretty short. That sorts this vector of integers that was passed in, and then we print it out. Okay, so that's the high-level structure of this program. Get a bunch of integers from the command line, sort them using this function, print them out. Okay, so this is what it does is not good though. So if we give it these input cases, we aren't getting the right values. Okay, but this is what your inputs are. So for this case, argc is 4. There were 4 words, and those values are this string, and then strings that correspond to each of the numbers. And for the second invocation, you get the idea. There'd be 6 words, and 5 of them are integers. Okay, so go to this online IDE, which actually has a debugger in it, and try to fix the bugs in this. And I want you to try to use these models, okay? Think about how to do this efficiently. So there's a relatively fast ways to do this, and there are painful ways to do this. A painful way to do it is to sit there staring at the code, because we intentionally gave you a sorting algorithm. It's not that easy to understand, okay? So that's part of the lesson. If you just sit there staring at the code, it might take you a while. But if you do things like use the wolf fence method, get some observations from the program, make a hypothesis, it's not that bad to fix, okay? So go to this website, https://bit.ly/2fupiun. And if you do that, it brings up an entire IDE, including a debugger, and you can basically compile, build, debug. Yeah. Ah, sorry. Which one is it? That's a lowercase l? Yeah. Okay, that's unfortunate. So maybe shortening the URL is not a good idea in this case. So, thank you. So you have it running in the yeah, that's a good idea. Yeah. You can set a breakpoint in the example things. In this case, you can also write, let's say, so you can basically you can single step to the how it's but yeah, this is kind of it's a good example of what that's I don't know what's wrong. Should I go start picking up this sorting function? And maybe it's not this right? In which case, this is all the time. So it's just going to pick a random part of code and sort of going to a really low level of what they're data function. So can you quickly narrow it down to where is the problem or problems? Let's see the things that are out there. So one and two is off. The shell was actually kind of so on a very efficient way to do sushi product, which is like that. So one way. You cannot get things per house. The lecture is exactly yeah. You have to want to be interested. Yeah. I think we get this one, but let's say I think that might be this. I think that might be if you're in charge, so I think they started like this. Yeah, so you gotta go down, that's where you stay. Yeah. Oh, this is. Right. So well, now you're probably there's no vacuum back here. Maybe for a small reference. Yeah. We're trying to get this years. Yeah, what is also what could cause this? Right? What are the things? The alpha is this case, it doesn't get much. Yeah.
Yeah, that was so funny. It was actually so funny.
I was like, oh, Justin, should I put our pictures? And he's like, yeah, do it. And then I do it. I was like, why does that actually look kind of shitty? It looks better now that you changed it. Some of my pictures out. I feel like mine is probably. I was going to too. No, but then they're all one height.
That's actually.
Some are all one height. This is all hearts. That's all flowers. That's and then I went to class and I
What is this?
no, that's just
That is the second one.
Yeah, no, we need to wrap up. Okay, so how many people figured it out? Figure out how many bugs? What bugs are in there? Go ahead. What's in there? Right, so the vector never gets stuff put in it. Anything else? Right. Okay, so it first didn't push back in the vector, and then it was kind of offset. It was taking a command name and wasn't taking all the arguments. So there are a couple of different bugs in there. How did you find that?
Well, the first time I just ran the program, there was no output. So then I went into the debug terminal instead of breaking point, right at the vector functions.
Yep.
And when I stepped in
didn't show up to the record, so I knew that it was loading in. And then I went back up and saw, basically worked through and looked at like where I was loading my string into and realized that code had been updated.
Yeah, so it's all good. So I would say you used a mix of kind of wolf fence method. I mean, you're observing it. So you're observing it in the debugger. You're checking where do I go wrong, and you see I never even get the data into this vector. So then you can zoom in on that part of the program. You don't have to look at this kind of nasty looking sort routine, which lots of people do. If they just start reading code, they go, that code's most complicated, I'll read that. And it might take me an hour. I'm drawing it out, trying to figure out if it's right or wrong, and it's a waste of time. And then you formed a hypothesis. You're like, well, and you also are like, there's no output. Okay? If there's no output at all, I mean, maybe something horrible has happened, right? So you kind of used, I'd say, a mix of forming a hypothesis, getting additional observations, and the wolf fence method. And yeah, so here are a couple of references that you can go look at if you're curious. But the idea of that exercise was the sit there and read all the code doesn't work super well when you start getting complicated code. As programs get bigger, it also doesn't work well. In the end, you still need to be able to read code because you narrow it down to a local region, you still got to figure out what's going on. But narrowing it down to a local region makes you hugely more productive than just trying to read huge amounts of code. So that's the lesson. Okay, thanks everybody. So.
When you